All right, guys, here we go. My next example is about math induction. Okay, I want to prove that the sum of the first n squares is equal to this formula here. Okay, so basically, I'm trying to prove, okay, I'm going to try to prove that 1 squared, the first n squares is 2 squared, 3 squared, 4 squared, and I can have as many as I want, okay, up to n squared. If I add all of these up manually, okay, up to n squared, if I add it manually, okay, will equal the same amount if I just simply plug in n into this formula here, n plus 1, 2n plus 1 all over 6, okay? Now, here's where people make a mistake, okay? So let me show you some examples, okay? So let's say, for example, n equals 3, okay? For n equals 3, in other words, you want to show that the left-hand side, the first three numbers added up will equal n equals 3 into here. So 1 squared plus 2 squared plus 3 squared. If you add it up manually, okay? If you add up these manually, you get 14, right? 1 squared, 4, and 9, okay? So you get 14. Or you can use the formula n plus 1, 2n plus 1 over 6. So I can plug in 3 into here, and I should get the same value, 14. So 3 plus 1, 2 times 3 plus 1, all over 6. So let's make sure that this gives you 14. So 3 times 4 times 7 over 6. All right, 3 times 4 times 7 is 80. 84 divided by 6, 14. Okay, so what we're trying to prove that is that for any amount of squares, you can add it manually or you can use the formula. Let's say n equals as many as you want, doesn't matter. N equals 6, for example, okay? 1 squared, 2 squared, 3 squared, 4 squared, 5 squared, 6 squared, okay? If you add it up manually, if you add all these manually, okay, let's check this out. Okay, you get 1, 14 here, 30, 55, and 55 and 36, so 91. If you add it up manually, okay, you get 91. Or it's a lot faster if you just simply plug in 6 into this formula. According to the formula, if you add it manually, you get 91. Or you simply plug 6 into here. Okay, let's check that out. 6 plus 1, 2 times 6 plus 1, all over 6. So 6, 7, 13 over 6. And so what we notice is that the 6 cancel, and 13 times 7 is 91. So if you think about it, if you had to add a bunch of squares up, would you like to do it manually or would you like to use this formula? Obviously, the formula is a lot faster, right? So what I did was I gave you two examples where this formula works for n equals 3 and 6, but that's not enough, right? There's still people that are skeptical. In other words, they don't believe that this works all the time. So what we're going to do is we're going to do the proof that this does work all the time, all right? So doing the proof, you have to do some work here, okay? So step one, all right? We are going to go through some steps here, okay? So step one, we're going to show, okay? We're going to prove, show, prove true for n equals 1, okay? In other words, just the first number, 1 squared, okay? this should equal what I get when I plug in 1 to the formula. 1 plus 1, 2 times 1 plus 1 over 6. Okay, so when you evaluate this, you do get 1. So this formula works. The step 1 is very trivial, very easy, but it's important that you do this just to make sure that it does work and that you wrote down the equation right. That's all. All right, so now step 2. Step 2 is, well, I've shown you that this works when n equals 1. And previously, I showed you that it works for n equals 2, n equals 6. I can show you as many examples as you want. So step 2, because I've shown you a couple examples, you're kind of giving in to the fact that, you know what, this does work. So then that's where you're going to assume that it is true. This statement is true for n equals k. Okay, so we're going to assume then that because that you've been shown a couple examples, that you're assuming that this works for some number up to k. So in other words, 1 squared, 2 squared, 3 squared, 4 squared, dot, 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 for n equals k. So plus k squared, right? This entire line right here, not just the last guy, okay? But 1 squared, 2 squared, 3 squared, 4 squared, dot, 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 up to k squared. All of this, we're going to assume that all of this equals k plus 1, 2k plus 1 over 6. Okay, the entire left-hand side equals this simple formula. Okay, now a common mistake people make is they say k squared equals this, and that's not true. K squared doesn't equal this. The entire left-hand side, when you add it up, from 1 squared, 2 squared, 3 squared, 4 squared, up to k squared, when you add it all up, will equal this formula. Okay, that's what the assumption is. So now we're on to step 3. There's always 3 steps in induction. Okay, last step here is we're going to try prove true for n equals k plus 1. Okay, so now that it's true for k, we're going to prove that it's true for the next guy. In other words, since you saw that it's true for 3, we're going to show that it works for 4. If it was true for 4, we're going to show it's true for 5. Since it's true for 5, we're going to show it's true for 6, and on and on. Since it's true for 6, it's true for 7. And so this goes on infinitely, forever. Okay, so now we're going to try to prove this. Okay, so in other words, 1 squared, 2 squared, 3 squared, 4 squared, plus dot dot dot, plus k squared. Now this is k squared, but we don't want just to do up to k. We're going up to k plus 1 squared. Okay, we're going to try to prove that when I plug in k plus 1, it will equal what happens when I plug in k plus 1 here. So the n, everywhere I see an n, I'm going to plug in k plus 1. So k plus 1 is in front. See the n there? Now it becomes k plus 1. This is an n. So when I plug that in, it's k plus 1 plus 1. And then I plug in k plus 1 there. So 2k plus 1 plus 1 over 6. Okay, so now let's simplify the right-hand side real quick. It's k plus 1, k plus 2, and then simplify this. It'll be 2k plus 3 over 6. All right, so I'm going to try to show that the left-hand side here equals this guy. Okay, now we always use the assumption to do the proof. Now the assumption says if you start from 1 up to k will equal this formula. So here's 1 up to k right there. From 1 up to k will equal k plus 1, 2k plus 1 over 6. And then the only new addition is this guy, like here. We're going to try to show that this added with k plus 1 squared will equal the right-hand side. Okay, so let's something we had to show that equals. Okay, so now we had to find a way to combine this to make it equal that. All right, so here we go. So we're gonna play little jealous neighbors, right? So jealous neighbors means I'm gonna take a 6 here and 6 there. That makes sense, right? So I can add these fractions. So now the denominator is gonna be a 6. Now I have k plus 1, 2k plus 1, and then here I have a 6k plus 1 squared. Okay, again, I'm going to try to show this equals this guy. K plus 1, k plus 2, 2k plus 3, all over 6. It doesn't look like they're equal, you know, but that's what I'm going to show. I'm going to show that this equals the right-hand side here. All right, so if you notice here, there's a k plus 1 right there. This is a k plus 1. This guy, there's 2 of them. So I'm going to factor that out. I'm going to take this k plus 1 out. I'm going to take one of these out. So k plus 1, take it out. When I remove this guy, I get k, 2k plus 1. When I remove one of these out, take one of these guys outside, I'm going to get a 6 left over and a k plus 1 left over, right? There was 2 here. I took it out in front right here. So there's 1 left over 6. So now look at it. I have a 6 on the bottom. That's good. It matches. I have a k plus 1 in front. It matches. Now here, I'm going to distribute k plus 1. I'm going to distribute this bracket right here. So when I distribute, I get 2k squared plus k plus 6k plus 6, okay, all over 6. I'm going to show that this equals, again, the right-hand side. K plus 1, k plus 2, 2k plus 3 over 6. I'm going to show that, okay? So, all right. So let's continue my process. So now I have k plus 1, 2k squared plus 7k plus 6 all over 6. Okay, so now this should equal k plus 1, k plus 2, 2k plus 3 all over 6. All right, so now how do you make 2k squared plus 7k plus 6 equal these two? Basically factor, right? Crossbone, right? Remember how to do crossbone? You get 12 and 7, okay? 12 and 7, what makes 12 and 7? So that's going to be 4 and 3. So go through the process of factoring this out, and you'll end up with k plus 1, 2k plus 3, and k plus 2 over 6. So your job is to take this and factor it to be this. So there you go. Now we have shown that this does work. Okay, that we, using math induction, prove that the left-hand side does equal the right-hand side. So there you go. Done. All right. So try that. If you're stuck on the factoring part, make sure you freshen up your memory on factoring. All right. Good luck on that. Bye.